In today's video, we'll learn about the instrumentation, working principle, and animation of gas chromatography. So here are the overall components. This is the carrier gas, which act as mobile phase. This is the column of our gas chromatography, and this is the oven, which control the temperature. Here is the detector, like flame ionization detector, and here is the hydrogen and air generators, which will pass the sample into the column. And we can see here these are the vials and samples. This is the auto sampler, which usually apply the sample automatically. And here are the overall working principle of gas chromatography. First of all, carrier gas will come from here, then we will apply the sample, then the sample would be passed through the column the using the mobile phase, like helium or hydrogen, and these are the coiled column. This can be of capillary column or packed column, whatever the column is. The sample is passed through, will be passed through it, and after that it will come into detector. Here we have used flame ionization detector. However, a lot of detectors can be used. We can see here the overall pathway of sample passing. So here is the auto sampler. It can be of different types like split and splitless. This is the carrier gas inlet. This is the auto sampler. This is the septum. First of all, carrier gas is passed through it. Then we apply the sample, and sample is been applied. So this is the split outlet. In the split process, usually gas and sample is separated. Okay, but whenever it is closed during the splitless method, then the carrier gas and the sample will pass through the column. So this is the basic difference between split and splitless. Okay, now after the applying the sample, it will come through column. As we have discussed earlier, it can be of two types like packed and capillary column. So let's see our analytes, our samples. For example, our sample contains three types of component: blue, green, and yellow. If we see, the green has lesser interaction with the stationary phase, thus it elute fast, followed by the blue, and lastly the yellow colored. So this is the basic principle of separation by column chromatography. It will then pass through the detector, and the recorder will detect the components or analyze the component or quantify the component based on their retention time. So these are the important factors regarding the column chromatography, like column temperature, carrier gas flow rate, column length, amount of material injected. These are the factors which will affect the separation of particles in the column. Now we'll see that the detector, for example, we have used flame ionization detector. Okay, how the detector will analyze the component. Okay, we can see here, this is the column. Our sample or our eluent will come by this direction. However, it will not come directly. It will get mixed with hydrogen because it need to be flowed. Okay, flow within the detector. Okay, so air and hydrogen will help this. So another function of air is ignition. So the sample will come through this direction, and igniter will inflame this. Okay, so the sample will be destructed or will be inflamed by the flame igniter. You can see here different electrodes, like polarization electrode and collector electrode. The sample will come from this electrode to the collector electrode, and whenever sample will come from here to there, this will cause some resistance or voltage or current, okay, in the collector electrode, and this current would be measured by the detector. So this is the flame ionization detector. There are so many other detectors used in column chromatography, in gas chromatography, like uh, ECD, electrical conductivity detector. Okay, then some other detectors. So this is the overall scenario of our gas chromatography, and the last portion is detector. In the detector you will see these types of peak. We need to analyze your sample by reading this peak. Okay, this is the retention time and this is the response. That is the area. Okay, you need to learn uh, the peaks by their retention time, okay, their solubility. As we have seen earlier, the green would be elute fast because it has laser interaction with the column, and followed by the blue and the red or the yellow on the very last stage because it has a greater interaction with the stationary phase. So this gives us the idea about different polarity or different retention of the analytes with the column. So this is the overall instrumentation and working principle of column chromatography. We can see here our components has been successfully detected. So if you have any confusion, please inform me in the comment section. Thank you.